Okay, so in this next section of the course, um, topic two, we're going to be talking about database security. All right, so some of the things we're going to be talking about, the key points of understanding we want to get out of this is data security, data availability, and then some of the concepts around including some of the security attributes required for auditing and for database recovery for when dealing with databases. Okay, so from an overview perspective, we've talked about this whole idea, like why do we have a database? Why are we using databases? And then fundamentally, the reason is we want to be able to control access to data. We want to be able to protect data, define data, um, be able to ask questions of the data, be able to preserve the integrity of the data. All right, so part and parcel of when we talk around databases, within the design of this database management system is all this capability um, that's around preventing unauthorized access to the data or disruption of the data. Right? And this takes a whole bunch of different forms. All right. The tool that manages this is the data dictionary. We've talked about this in our first section, kind of which one of those internal components within the database management system. The data dictionary controls most of the data access control within the system. Um, and really what it does is it controls each user's access to the different data items in the system. All right. In addition to this kind of protecting of the database internally through the data dictionary and the functions provided by the data dictionary, we also want to have physical security. Physical security trumps everything. In a lot of cases, if you get access to the uh, physical systems or networks or databases, you have, your integrity it can be significantly compromised. Right? So that's kind of our overview going into this. From a CIA perspective, so when we talk about the CIA, there's three concepts, or there's three elements that we are really the goals and objectives of security, of information security, and they are confidentiality, integrity, and availability. So we call this the CIA, or sometimes you'll hear this term called the CIA triad. If you work with security, in any way, you come across this. This is a core fundamental concept. So the idea of confidentiality is users should not be able to see or access data items that they are not supposed to. So no unauthorized access. From an integrity perspective, users should not be able to modify data items they are not supposed to, whether by intentionally or unintentionally. It really doesn't matter the intent of someone if the outcome of is corruption of a database, whether somebody intended to do it or didn't do it, or did not intend to do it. The outcome is still the same. You still have a corrupted database. And third, availability. Authorized users must be able to see and modify the data items that they're allowed to when they want to do it. So basically, the availability. If you don't have availability of the data in the database, you really don't. The database is not doing its job. All right, so the CIA triad is really a core, kind of a core component, and database security, reflects all of these different of these three elements that are baked in. Auditing databases. So the idea is you want to be able to examine and prove the reliability and the integrity of it. Remember we talked about the most important thing about a database is that we protect the data so that when we ask questions, we know we are assured we get a correct answer. All right? And if you have bad data, you will never ever get a correct answer. All right, so the security control mechanisms relevant for other information systems are also relevant. So it's not simply a database thing. It's also for any other type of in broader applications of system security. So there's three types for database systems. There's three types of additional controls um, that we're dealing with. One is this idea of update and access control. Then we also have a coordination of activity control, and then concentration of resources control. So this is, over and above the auditing. So the auditing is really a field unto itself, form of, a branch of accounting, and they have their own, their own definitions and structures and rules that they follow. Database systems have three additional sets of controls that are applied to this. That's what these three are. So the update and access control, basically making sure is that we protect the update, the ability to, update and access, update data. So it's create, retrieval, update, and delete. CRUD is the term we use for that. In concurrent access concurrent access controls. All right. So database systems, basically what a database management system needs to have is the ability to restrict users and, to access and only modify things they're authorized to touch. All right. And then in addition, users should also be protected. The DBMS also needs to protect users and the data from problems associated with concurrent access. So if, the idea of a database is a shared system, it's a shared resource. So if I have 3 or 4 people going, into this database and making updates at the same time, we have to manage and maintain control of that. All right, to make sure that somebody makes half a change, and then somebody else comes in and makes another change on top of that, and then the first person comes back in and tries to complete their change. Right, that's what basically, the idea of creating this stuff in a queued fashion, in an orderly fashion. So, we break things up into units of work where a change is applied appropriately, and also we maintain the ability to back out that change and also be able to track when that change occurs and kind of who was responsible for doing it. One of the things here is we talk about the separation of organizational duties, determines authorization to prevent any single compromised account from exposing the entire database system. So the idea is part of what you do is when you set up accounts and you grant people access, you don't grant people total access to do anything they want to any table in the system. That's kind of what this area, this access control is talking about. So the idea is what you want to be able to do is you work on, you only touch the stuff that you have rights to touch to, or you have a business need to touch. And if you don't have a business need to touch it, you don't do it. You don't have anything to do with it. You can't see it. You basically are only you're only allowed to touch the stuff you have the rights to do. And then the database management system enforces as the mechanisms within it to enforce that. Coordination of activity control, basically making sure that all of this shared data, software, hardware is properly coordinated. Right? So we bake things into the DBMS functionality to enforce different levels of control for data items. So basically, who has access to it, who can manage it, who's doing what with it at any given point in time. We talk about this idea of shared because it's a big, it's really a big concept because we have one database. This is not, if somebody has a spreadsheet, they're doing stuff by themselves. But in this idea of a database and a database system, everything is shared. So the idea of maintaining things in a consistent fashion so that if somebody sees something, if you define something, everybody's playing by the same set of rules. You interpret everything the same way. It's not something we want to be negotiating. Okay, here's this data element A. One side of the organization says it's this, other side of the organization says that, and then you have a philosophical tete-a-tete dealing with who's right and who's wrong. That's not the situation we want to be in. So there's a consistency of the way data is interpreted. And then finally, this idea of coordination of shared data usage with accessing data when needed. All right, so it's really the idea of coordinating across coordinating everything dealing with this idea of a database being a shared platform. And then we have the concentration of resource control. All right, so the idea is what this means. It's a fancy way of saying basically the database is contains consolidated information. So the idea is, by concentrating everything into one point, um, theoretically, if that point gets compromised, you've compromised everything. So the idea is being able to also, manage the physical control, database, the physical resources, which is, physical controls. We talked about physical access is extraordinarily important in the security realm. It does not. There's nothing we do at the system level that necessarily replaces or eliminates the need for physical security. All right. So the idea is being able to protect all of the different data structures, the physical database structures, so somebody can't come in and copy it and read it and do all sorts of stuff. In addition, the other thing that is part of this concentration, this kind of, this having a single point of data, or single storage of data, is you got to make sure we can back it up and recover it. Right? There's nothing worse than creating like a 5 million row database and then having somebody come in and blowing it up somehow, and then not having the ability to put that back together. These databases reflect a lot of work over a long period of time, years and years of data. So it's a pretty important asset. All right, and one of the things that database management systems, DBMSs, have within them is the ability to back up and recover. So the database, and this is, once again, this is baked into the DBMS. So database, it must mitigate. The idea is these controls, these tools, these capabilities, when used, enables us to mitigate the risks of losing stuff, human error, malicious behavior, acts of God, whatever would come into place that could potentially damage, that would potentially damage this consolidated collection of data. Well, just a bit more about physical security. It's only people who have the need to get to touch the system or have physical access to the system. So this is, putting things into secured locations, combination locks, physically protecting from like fire protection. So halon, which I don't sure use halon quite as much. It was one of those products that was used for fire suppression, but it was actually causing issues with the ozone layer. So there's new fire suppression equipments, but tag controls, things like that. So these are all trash, which is kind of an amazing. Trash is an interesting concept in security, because if you ever hear the term dumpster diving, people would go, if you take a look at what people throw away in the trash, astonishing amounts of information can be dug out of a trash can. People go dumpster diving and find all sorts of fascinating bits of information. So part of the stuff you want to make sure you have controls around and put procedures in place around is the disposal of trash, making sure that documents containing proprietary information aren't thrown away, and can be recovered and the information leveraged. All right. DR, disaster recovery. Disaster recovery is a fact of life in information technology. The possibility that something could happen to your system, of any nature. So disaster recoveries can range from complete absolute destruction of a facility to things like losing power for extended periods of time, or losing a piece of a piece of infrastructure, or a piece of a system. Like if you lose your storage and you still have all your compute power, that can be as much of a disaster if you blow up the entire data center. All right. So the idea is creating a plan to be able to recover stuff, and to be able to test and review that plan on a regular basis. So just in case something happens, you have the facilities, the capabilities to restore things back to a reasonable working level within an acceptable period of time. All right. So the idea is the inadvertent destruction of important database systems by persons with authorized access from human errors must be recoverable. So a disaster could be you blow up, if you accidentally blow up your data center, or somebody flushes the toilet and the entire building floods out for some reason. Basically, all these things can happen, or possibility can happen. You need to be able to be able to recover the databases from that. Okay, so the idea of a database, one of the things that we have within a database is this ability to do a database recovery. Okay, um, the and this is once again the functionality that we're dealing with here is really stuff that the is baked into that to the database management system. So there's capabilities in the database management system to handle all this stuff. So the idea is be able to back things up, to be able to back up, do full backups, be able to do incremental backups, be able to do recovery, to be able to do identify particular checkpoints. So checkpoints are the ability to recover data back to a particular point in time. Right? So in well-designed recovery situations, we can do a recovery. We can do a database recovery back until the up until the minutes before we recover all the changes to the database, the state of the database, up until the point where the system had gone down. All right, so there's a transaction. So part of what the database has within it is something called transactions. The database operates on this idea of a units of work that we call a transaction. All right. And what we have the ability to do within these, we can recover. The way we do recovery in a database is through this idea of a transaction. So it's really think of a transaction as a unit of work. We do X amount of work. Okay, we search for a bunch. We search for a bunch of data in across a bunch of tables. We write some queries. We get some data. We bring it back. We make some changes. Which can be either updates or deletes, and then we complete the transaction. All right. So what we do is before we begin, we take a checkpoint before we begin. It is our starting point. We do X amount of work. We do the query. We do the updates. And then at the end, we do when we're completed, we do another checkpoint. So basically, we do, as we call a commit. And what the database is actually doing, the database management system, is actually writing all the stuff that's going on to another file. All right. So we're not just updating the database itself. We also have other mechanisms in there where all of this stuff is being captured. That we can go back and then we can then go back and use that information in case of a situation where we had to bring a system back from a damaged state. So just some other terms, the terminology: transaction, logical unit of work in databases. Basically, what it means is it's either a create, a read, an update, or a delete. Once the transaction is completed, it's ready for a commit. And the transaction is not completed, is not committed, until the transaction is committed, there's nothing permanently written to the database. All right, so we have the ability to either commit or we can roll back. And if the system was to crash in midstream, so say for example, you're halfway through, you've got a whole bunch of stuff you're doing, and you're halfway through, and something was to happen to the system, when the database starts back up, when the database will come back up, what it will do is it will know that it had work that was still pending, and it will roll all of that stuff back, and you will pick back up where it had left off. So this is an important part of the database. This is part of the DBMS. This is part of the database management system software that does all this stuff behind the scenes. For the most part, if you're an end user, you don't see any of this. Right? You see this if you're a database administrator. But for the most part, this is all part of the secret sauce that the database management system brings. We talk about logging. This is the information that identifies the transactions and data that goes into this. It's maintained. It's actually another file. It gets captured. And put onto another storage device. So as we call it, the term we use here, we call it an after image. So what's happening is there's a whole bunch of stuff that's going on as the database as we're doing work in the database. All right, of which we don't see it, but what's happening is all of this stuff, as changes are being made, as things are being, as modifications are being made, the stuff is actually capturing everything all along the way. So it's not just simply writing stuff onto the file, it's writing stuff onto the file and it's writing stuff out to log files. And then we can have the ability to go back and use these, after images and actually recover a database in case it was damaged or if in case there was some circumstance, some unexpected circumstance. So let's talk a little bit about the user IDs. The way you grant access into a database is through the creation of user IDs. So you get an ID, and your ID is granted rights to do stuff. All right. So the user ID is kind of our starting point. All right. And there's two concepts. Once again, these are concepts that are broader, not just simply limited to databases. We do this in systems across the board. But this is, we leverage this kind of broader concept of authorization and authentication. We blend this in with, we blend this into our database model. All right. So what we do is we create users. A couple things we need to do. So we creating a user, which is basically how we grant people the ability to access it and authenticate. What you do is there's the difference between authentication and authorization. Authentication gives you the ability to present your credentials to give you initial access to the system, be able to just log on. Authorization it goes further and grants you the rights to get to the data that's in there. So authentication just gets you in, is a starting point, but you need both authentication and authorization to actually do anything in a database. All right, a couple things we need to do, so obviously we need to create users, but in addition, some of the stuff from an administration and from a security perspective, we need to check for default users. What a default user is when we create the software, the DBMS software, when we start the system up, when we install it, what will happen is there's no user IDs in there, but there are a lot of times they'll put default users that are known, if you read the documentation, you read the manual, you'll see the name of you'll see the default user and you'll see the passwords, default passwords that goes with that. One of the things from a security perspective, the database administrator needs to do is go back and check all these things and make sure you either remove those accounts or lock them up or change the passwords. All right, because basically if I'm a hacker and I get access to a system, the first thing I'm going to do is I'm going to check everything that the book says it should be a default account with the default password. And you won't always succeed, but all you have to do, all you need to do is once if you're a hacker. All you got to find is one mistake. All right. And then the other thing, the question about weak passwords. So the idea is, you want to use something other than like the word password, or somebody's name or somebody's last name or your pet's name or your kid's name or something like that. The creation of passwords, the management of passwords is a pretty big part of the security associated with databases. So password policy. So actually, it's so important. What we do is we actually create written policies around how we should construct passwords, what people should do, since it is the key. All right, and user authentication depends on passwords. You have to do, really it's a matter of training, it's a matter of education, it's a matter of defining a policy. So some of the guidelines, a policy is a set of guidelines, so the idea is to define what we mean by a robust password, and constructing a password in such a fashion so we do not, we have reduced the likelihood of somebody being able to guess it. All right, so it deals with complexity, the complexity of the password, how many the length of the password and what it can be made up of: letters, symbols, capitals, lowercase. Also, the number of attempts. By default, if you don't set a limit on the attempts, you can just somebody can guess and guess and guess and guess. All right, and eventually, if you have, and especially if you're using a program to do it, eventually you might come across you might hit the right password. Change frequency. Obviously, a password should not um, last forever. Basically, it needs to be changed on a regular basis. Defined basis, should be defined in the policy, as well as the reuse. All right, you don't want to keep using the same password again and again and again. All right. So these are all things that are written up, and once again, not limited to just simply database and database work, but it is part and parcel of a overall security of which the database work is, our database management is part of. Right? Designing it, as we just said, complexity, aging, how long, usage, how many times it can be used, and then storage, making sure that passwords are encrypted. One of the early things we used to see when we used to send, and people used to send, access across the internet, was data was transferred in clear text, and that part of that data that would be transferred would be the username and the password. So all somebody needed to do was get a sniffer, which is basically a piece of software that can run on a laptop and just read packets off the network. And you gather a couple 100,000 or a couple million packets, and you do some, you run some analysis on it, and you can extract out and identify passwords. So the idea now is, all your data, your passwords really need to be treated as encrypted data. All right, so just some words on different types of security models. There's a whole bunch of different types of security models, which have applicability. They're broader concepts, but they have applicability in this, within databases. So it's the, what we call an access matrix model or modes model or security models. And then we have mandatory versus discretionary access controls. And then finally, role-based, RBAC, or role-based access control. Okay, so we talk about an access matrix. So kind of this first model we're going to talk about is a matrix model. So the idea is the concept is simple. What we do is we match up a list of the objects in the database versus the people who are going to be using it. All right, so it's really kind of a column, basically a matrix where we have peoples and things. All right, so columns are the objects, the rows are the people. All right, and we have what we call where the two intersect. The term is, and it's an authorization cell. All right, kind of a picture of it. Pretty simple. What we do is we have X number of tables within a database, and the people. So we do is on the one matrix we have, on the one dimension we have the users, and then we have the tables, and then basically within each cell what they have access to. So it's a pretty simple model. Now the challenge is, as tables get larger and larger, or the numbers of tables we are dealing with get larger and larger and larger, that becomes more challenging to manage that, or numbers of users, because you can have thousands of users and thousands of objects. So it works well for relatively small, straightforward applications, but as we scale this stuff up, sometimes we run into challenges. Then we have a role, application against application users. Basically, each user is assigned a role, and then the roles have privileges assigned to them. So this concept of role-based access is a means by which we can scale this stuff up. So rather than having to, because if you look at this, in this other matrix, we're managing everything on a user-by-user basis. All right, and what we want to do is we need to really make sure that, in order to simplify that, what we want to do is we want to maybe consolidate all these accesses into like a common role, and then the roles can be assigned to people. All right, so pictorially, what we have here is this idea of of a comment of a access of somebody doing a particular job who needs to do certain work against certain tables, um, and we can have maybe 3 or 4 or 5 or 50 people in that department. So what you do is we would create this model and then allocate that model to however many people who would be doing that particular job. So as we say, application roles map to real business roles. You can, there's a bunch of different variants around this. So there's role-based model is a fundamental concept in security. There's a lot of different kinds of implementations. In this case here, we say we can take application roles and map them to business roles. That's a possibility. Or you can just simply create just an overall combination application slash business role, which would implicitly have application roles within it. All right. Kind of a picture of this. Application functions, you can do, you can chop this stuff up and you can break things up into functions, which kind of is a little bit, functions, you could say a function is kind of like a role, kind of the idea of a, kind of the advantages of setting this up, as we see is similar to what we see with the idea of the role. One of the challenges you run into with some of these things is if you become more granular. So some of these things, the reason you want to split these things out is, okay, I want to have more control of things at different levels. So I create applications and business functions. Problem with that is every level we add into the mix makes it more complicated. So the challenge is you're trying to strike the balance of, okay, we want to have adequate coverage on our security, but by the same token, we want to make sure we're not, adding all sorts of additional work, because what will happen is the more complicated we make it, the more challenge, the more opportunities for mistakes, and the more opportunities for mistakes is where we're going to run into problems. Okay. Kind of a picture, application function model. Or we can do combinations of these things. So all these things are different, can be broken up. And the advantage is when you combine them, you kind of combine some of this, you have flexibility to combine different things and operate them in different ways. All right. So kind of another diagram of it. Kind of an overall, kind of a view of the different roles here, kind of some of the different strengths, some of the characteristics of a database role, application function and role, or application table. All right. So it's your simplest ones, your application just simply doing allocating roles by tables is your simplest ones. Other than that, you're probably going to use some combination of a role, defining some type of role, and then assigning people to that. Some more characteristics. So that we talked about, we create the user ID, that basically user ID that somebody would use to authenticate themselves and then be granted authorizations to. By default, you have nothing. All right. So by default, you basically have no rights to do anything. All right. So what happens is you have to be granted access. So you get access, you get granted access to the object, and then you also get granted what you can do to that object. All right. And then once you're granted, you have the ability to do stuff, and then when you want to remove that, you say revoke. All right. And then if you want to deny permissions, you want to take permissions away, you use you use revoke, and then if you want to just simply deny permission, you can use a deny statement. So role-based access control, which is a kind of a general, we use this a lot. I mean, I use this in business. We see this used a lot, this whole idea of defining this idea of roles and permissions. All right, so rather than operating at the lower levels or functions and things like that, what we do is we just simply create a role and a permission, and and then the permissions are assigned to the roles, and the user assigned to the roles. So you kind of, part of the stuff we're doing is the challenge you run into with security, especially with things like databases, and we have the same thing in operating systems. The more complicated, the more granular we get with this stuff, the more complicated it gets. All right. So what these idea of the role-based, these concepts we're bringing forward here, are really designed to make these things, is try to make this stuff simpler. All right. So kind of a traditional access control, a user is granted access to an object. In the role-based, users are assigned to roles, roles are assigned accesses to objects. All right, so the idea is once you define it, I have 1,000 users. I define one role. I can put 1,000 users in a role. And we know that all 1,000 of those users are have the ability to do. So, you have all these different relationships: role permission relationship, user role relationship, role relationships. Some of the details around this. All right. So the idea of, basically, collectively, all these things combined will determine whether a particular user is allowed to access a particular piece of data in the system. All right. And then the idea is being able to do this stuff in a standardized way, be able to establish policies, enforcement at a granular level, but be able to standardize that kind of across the board. So kind of just another pictorial view of this. The idea is the reason why role-based access control is so popular, it really does reduce the complexity of the administration. All right. So we're not dealing with, trying to match individual objects to individual users. We're kind of we're kind of restructuring it in such a fashion so we can, we can manage it in a more effective way and be able to get more consistent policies, more consistent application of rules. So, the more consistency we have, the less opportunities we have to make mistakes, less mistakes we make, in the security world, means that we're doing, less mistakes means less possibility for security vulnerabilities that somebody can exploit. Just a couple more things about RBAC. There's 3 well-known security principles, something we call least privilege, separation of duties, data abstraction. The idea of least privilege is least privilege means that basically you only get the absolute minimum number of privileges that you need to do your job. All right, so you get nothing beyond that. All right. Separation of duties ensures that individuals can only have the ability to do certain types of functions, not on an end-to-end basis. Like, for example, if I give you full access to a database, to all the fields in the database, you can do anything you want with it. So the idea of a separation of duties is, okay, I have 2 or 3 people. One person is responsible for one piece. Another person is responsible for another piece. Third person is responsible for a third piece. And no one person can do everything. All right, which is important from an auditing perspective and from a controls perspective. Right. Discretionary controls versus mandatory controls. Basically, what discretionary means, object owner can set access, who can get access to it. All right. So it's used. We see this more in operating systems. I don't see it so much in data. Not exactly databases. Though you can see discretionary controls in databases. All right. But this is kind of a broader concept. It's not there's no organizational policy because everybody kind of decides what the policies of their data is going to be. All right. Good news is it gives you lots of flexibility. Bad news is you don't have as much control as would be desired. All right, so you can, and if somebody was to come in, software running, if you can get access to control of the objects, you have pretty much free reign. You can do a lot of stuff. So you see a lot of software attacks, software hacks are focused on you know, getting, kind of focusing on discretionary access control policies and be able to try to modify them. Right. With databases, we, as I said, it's more common at the operating system level. For databases, we do see it, for DB objects, but I think you see more, it's a little less, it's not quite as prevalent. You can do things like, for example, the grant revoke commands. You can invoke a discretionary, you leverage discretionary access controls. Mandatory is the opposite. I mean, if you can think of the opposite ends, if discretionary is everybody can set their own access control policy, mandatory access control means that, basically there is one system administration which is defined, and everybody adheres to that. All right. And what we see is actually not so much, it's not necessarily either or proposition. A lot of times it's combinations. So you see combinations of some things being defined as discretionary, some things being defined as mandatory. So as we say here, each database object is assigned a class. Each subject is assigned clearance for that class. Then rules can be established around that. The idea is, the database with mandatory controls, we can prevent the use of databases as a channel for secret information or different kinds of things. So there's different dimensions of mandatory. There's certain scenarios where where mandatory will come into place, and others where we'll see discretionary. And it really depends on what you're looking at any given point within the world of database administration. Data encryption. By default, the data that's stored in a database is simply data. All right, so it's not necessarily, if you can get access to it, you should be able to read it. All right. So, data encryption is protection of authorized access to data. All right. Doesn't provide absolute security. All right. So what happens is the expectation is you take some data, you have an algorithm that will convert that data, and you have a key that is used to drive what the actual output will look like. All right. So the idea is you can you can protect the data. You can actually transform the data to make it non-readable, to for as opposed to clear text. The problem is you also have to make sure you maintain and protect the key. You don't protect the key, then the encrypted data is no safer than it is without the protection, without the encryption. All right. So you see a couple different different techniques. This is also implemented on a database by database basis. Each platform. Some systems use data compression to reduce space. Encryption can perform the compression at the same time. So if we use a combination of compression and encryption, kind of at the same time, and a lot of this stuff is now baked into. They're actually baked into database management systems now. So it's something that kind of comes with. You don't have to do it externally. You just kind of set it up, and it'll take care of it all for you. Password encryption. Passwords should be kept confidential at all times when you're using encryption, and be able to manage them. Passwords should be compared using, the idea of you encrypt it and you create a hash in passwords, and then you compare the hashes. All right. So, and we'll talk a little bit about kind of encryption and pass in our next section here. And that is it for this introduction to database security.